Good morning, everyone. I'm Balaji Krishnapuram. I lead the Content Engineering and Core PADS team at Pinterest. I would like to start by extending each of you a very warm welcome to our fourth annual Machine Learning Conference. We are very glad you can join us today. With this conference, we aim to provide a space for collaborative knowledge sharing, and we highlight how Pinterest is leveraging machine learning to build an engaging, innovative, and inclusive product for more than 450 million pinners each month. Today, we bring you a captivating speaker lineup featuring Pinterest's world class machine learning team. We have planned a thought provoking agenda filled with lightning talks and panel discussions, along with a networking lunch. Each session will include a short Q&A session where we will be accepting audience questions. We encourage you to first use the chat feature to add your questions. Here's the rest of the agenda for the day. Our day starts with a keynote session, followed by a panel with some of our senior leaders. Our engineers will host 5 lightning talks, and we will wrap with a technical panel where we will provide insights into the expertise and experiences that our panelists have in building our product. This year, we look forward to hosting an optional virtual networking lunch as a space for you to connect with other invitees and attendees via our event platform. Lastly, we will have small breaks between sessions. Now, before I introduce our keynote speaker for today, I'd like to take a minute to thank and acknowledge our amazing planning and support teams, along with our event speakers. They've been working tirelessly behind the scenes to put this event together. Thank you. Once again, I'm very excited to welcome you all today, and I look forward to another successful ML Day conference. We hope you enjoy the event. Jumping right in, our first session is by Liang Zhang. Liang is a VP of Engineering for the Pinner Discovery team at Pinterest. He has a PhD in statistics from Duke. He has been building cutting-edge ML products at Yahoo, LinkedIn, and Pinterest for the last 16 years. Today, he will talk about how machine learning helps Pinterest bring pinners the inspiration to create a life they love. Please welcome Liang.
Thank you, Balaji. And good morning, everyone. Welcome to Pinterest Machine Learning Day. My name is Liang, and I'm very excited to give keynote speech today to talk about machine learning at Pinterest and how we use machine learning to provide our pinners a journey of inspiration to realization. I would like to start with introducing myself first. I've been at Pinterest for the past 3 years. I currently lead the Pinner Discovery Engineering team, who are responsible for end-to-end development for 3 major surfaces at Pinterest. The home feed, where all of our users land when they open the app. The search tab, where you use a query to search for the results you want. And the close-up experience, where the pinners click to view the details of pins and browse the related pins. My team have been using machine learning as a key technology to power a relevant and engaging experience on these surfaces for our pinners. And I'm very excited to share how machine learning looks like at Pinterest today. So the goal of today's talk is to provide an introduction to Pinterest and also give all of you a high-level overview of machine learning and Pinterest, and also its applications in our production. Hopefully, this will provide a context for the rest of the talks and panel discussions today. I would like to start with introducing Pinterest's mission, which is to bring everyone the inspiration to create a life they love. But what does this really mean? How do we do it? And what role does machine learning have to play? This mission is what guides our product directions and is what has made Pinterest unique. Pinterest is the home of inspiration. People come to Pinterest to find ideas such as what recipe should I cook for breakfast this morning, or look for aesthetic designs for your next home remodel, or the dresses you may want to buy for this fall season. We are an inspiration to realization platform. We help users to find inspiration and then realize that inspiration, to take action, to create a life they love. So they come with they come with a strong intent to do or learn something and then take action. Our pinners are coming to do something for themselves. It is not mindless scrolling, but it is me time. It adds a lot of value to their daily lives. Hence, one of our most important corporate values is put pinners first. As we just talked about, people come to Pinterest with intent to go from inspiration to action, many times on a long-lived journey across multiple stages. So Pinterest is not where people mindlessly scroll through the dance videos or engage in flame wars about politics. Our pinners come to discover their next great ideas. They come to decide by searching for specific ideas and making plans with them. Then they come to do by buying and trying ideas on Pinterest. To go a little deeper into the app, we have three primary surfaces that forms the discovery experience. First is home feed, which is what they see when they enter the app. And we recommend the pins according to users' interest. The next is search, where our users use queries to find ideas they like to act on. And the last but not least is close-up, that provides the details of the pins and also opportunities to refine the ideas or explore similar ideas through related pins. So how big is Pinterest? Well, we have more than 482 million monthly active users. We also have more than 475 billion pins. We have greater than 10 billion boards created by our pinners. We operate on more than 40 plus languages. 91% of our pinners say it is a place filled with positivity. So Pinterest has a very unique, curated set of data at a massive scale, which captures how people describe and organize things to enhance the life they love. With 475 billion pins saved and 482 million monthly active users, our job is to be able to serve the most relevant, engaging, and actionable content to our pinners when they visit our app. So you may be asking right now, how are we going to use machine learning to go from a sea of content to facilitate the user's inspiration to realization journey, which is Pinterest's mission? So let's start from the data and signals, the basics of any machine learning technology would rely on. So what does the data at Pinterest look like? Let's get even a bit more concrete and break Pinterest down into the components. First of all, there's the pinner or the user, and the app itself, which is Pinterest app. And then there's a pin, which is the basic unit of content. It can be image, it can be a video, it can be a product, it can be an ad, but they all come with metadata. The pinner would come to the Pinterest app, sees these pins on their home feed or search tab, and then they may decide to take a close look at the pins by clicking on them. We call this a view of the pin. When the pinners feel that they are inspired by the idea of the pin, they may decide to save the pin to a board, which is a collection of pins saved or curated by the pinner. The pinner might also decide to click through, which means they click to visit the external websites so that they can perform more actions such as purchase, or sharing the pin to their network so that their friends can also get inspired. The pinners can also decide to comment on the pins. So the key point here is that there are massive amounts of data at Pinterest for machine learning models to learn from, including the detail of the pins, There are also a lot of Pinterest behaviors and actions like views, saves, click-throughs, shares, and comments. Those are the interactions that our pinners do with the pins at Pinterest. So all these form the massive data at Pinterest that machine learning models can use. So now let's talk about, start from the pin. What is a pin? First of all, the pin might have different formats. They can be images, they can be videos, they can be product pins for our pinners to purchase, or even an ad. A pin usually contains a lot of metadata, such as the creators or curators who generated this pin or published the pin, title or description that are created during the creation process. There can be attributes like brand or price if this is a product pin. There is an URL, which we can actually obtain web crawl data from the landing page of the URL. And we also have all the past pin interaction data aggregated for the pin, such as the number of views, such as click-throughs, saves, shares, comments, etc. So all these provide very rich content signals for every pin at Pinterest, and our machine learning models are able to utilize these signals really, really well. The other important concept is the board. So the board is a curated collection of pins which are saved or pinned by a user. This is a manual curation process, and users can create multiple boards about different topics. For example, cheers, recipes, etc. And each board can contain many pins saved by the user. This is a common behavior on Pinterest, and save is one of the unique product features which help our pinners to organize the pins that they are inspired by so that they can carefully plan for their live events and also take actions such as purchases later on. What is really powerful about boards are that they represent very nuanced tastes and understanding from our users. I'm going to give an example here. Let's say this is a kitchen pin, and there's one user coming to Pinterest, and they may be focusing on these blue accents that you see in the kitchen pin. So this user has a blue accents board that has a lot of different furnitures that are really focusing on the color blue. Then another user saves the exact same content into a board for vintage kitchens. This user cares more about the aesthetic style of this image, and they organizes their board to reflect that style. Lastly, this may be a little bit hard to see, but there's also a little fireplace in the pin image, and some people do save that pin into a fireplace board. So what can we do with the pin board data? Well, we can create a pin board graph. What is really interesting about this graph is that the same content saved into different boards parallel how the users would organize and describe the knowledge in their own unique way. This is very important to Pinterest because the pin board graph provides a way to capture relationships and similarities among the pins that are organized by boards. But how can we utilize that graph? One way is a random walk and looking at the visitation counts, which we call Pixie. And it has been widely applied in our retrieval systems at the Pinterest recommendation system and search as well. But we can do better than that. So PinSage is our solution to this problem. PinSage is a graph neural network that allows us to combine visual and text information into each pin with the pin board graph. To make this work, we had to reduce the full graph down to the most informative 3 billion nodes and 18 billion edges for this work. But that is still one of the largest in the world. The PinSage embeddings have been widely used at Pinterest. There are more than 70 production launches which have generated significant impact. to our engagement, to our revenue, and etc., and provided a great product experiences. Since Pinterest is very visual oriented and a lot of product features also heavily depend on our vision technology, we have trained a billion parameter vision model using multitask learning, and it generates an embedding for each image and can do inference in near real time. This universal visual embedding has been widely adopted across Pinterest in 30 plus models or systems, powering a lot of vision-based products as well. On the pinner side, I would like to note that pinners come to Pinterest with highly valuable intent signals. They search and browse. They curate content and save them to boards. They share and comment on the content they like. And they also click through to external sites to do further actions, such as purchases. So the question is, how do we use these signals in our machine learning models? The answer here is that we can generate user embeddings according to our pinner's past interaction history. So we have a transformer that encodes their past activities and uses those to predict their future actions on pins where the pins are represented by pin stage embeddings. The pinner form embeddings had 10 plus launches and had had a lot of impact on engagement when we incorporated those signals into our machine learning models and systems. I would like to call out that this is one of the greatest innovations and in terms of machine learning technology. And also, it has been driven a lot of gains in our machine learning models as well as product features. So with this data and signals, now I would like to talk a bit about the machine learning powered recommendation and search systems at Pinterest. These systems enable our pinners to have an inspiration to realization journey on Pinterest discovery surfaces, including home feed, search, and related pins. So let's use home feed as an example. And this is a very common machine learning architecture, and it is generally applicable to related pins and search as well. The only difference is that the search would come with a query as well. But let's say for home feed as an example, when a pinner visits home feed, we will first retrieve the relevant pins through candidate generators according to the pinner's interests, represented by their past activities. The retrieved pins then will get passed through the ranking models to score. And the main objective here is to predict the probabilities of user actions on these pins. Afterwards, the action probabilities of these pins were blended into the utility functions to represent different business trade-offs. And the final ranking of the pins will be formed to optimize and balance among different business metrics. For home feed, we need to balance the trade-offs among the actions that represent pinners' inspirations, such as saves and shares, and maybe comments. And also, there will be the metrics that represent pinners' realizations, such as click-throughs and conversions on the external websites. And next, we also need to make sure that we can balance the trade-off between the pinner utilities with the revenue generated from our ads. So we call this whole page optimization to be able to balance the pinner utilities and revenue on Pinterest, recommendation systems and search. So you can see that this is a very generic step-by-step system like layers, but it also is how we use machine learning to support all these recommendations and search to serve a very engaging experience of our pinners at Pinterest. So let's start with the retrieval to go a little bit more into the details. During the retrieval, which is the candidate generation step, we have developed learned embedding-based retrieval, where we leverage the two-tower architecture, which include one pin tower and one user tower. Both towers take content and user signals as input and jointly learn the embeddings using the home feed user interaction data. Since the dot product of the pin embedding and user embedding is the score for the retrieval, we can use approximate KNN methods such as HNSW to efficiently retrieve the candidates given a user embedding at runtime. This architecture has been very, very efficient in incorporating any machine learning signals we built for our users and content. And it also has generated continuously engagement improvements as we keep adding signals and innovating with our machine learning architecture. During the ranking step, we have a multi-headed ranking model that scores the probability of a user taking different actions to pins, such as views, saves, click-throughs, shares, etc. We also have the downstream rewards as heads in our model, which means the user's downstream actions in the same session after acting on the pin. We incorporated the user's past acted pin embeddings, the pin stage embeddings, as a sequence using transformers into the model, which makes the model really large. You may ask, how can we actually be able to serve such a large model with transformers in our production system with low latency? The answer is that we have optimized our GPU-based training and serving using mixed precision and CUDA graph optimization, so that although the model size has increased 100 times, the cost increase and latency increase are actually very, very little. So this is yet another great innovations that we have in our machine learning systems at Pinterest. In the blending layer, here the main problem to solve is how can we balance among different action probabilities that our ranking model have scored. So we also recognize that different pinners may have different affinities to their actions that can fundamentally drive their retention and engagement. That is why we have learned personalized ways of actions for each pinner, so that we can serve according to their past behavior and interests and affinity to actions. We also did whole page optimization to jointly consider the trade-off between the pinner utility and ads revenue. So now, let's talk a little bit about some other interesting machine learning powered product features besides the traditional recommendation systems and search systems that we just talked about. The first thing I want to say is at Pinterest, we have made it a priority to build an inclusive product. We want every user, regardless of their background, to feel celebrated on Pinterest. First, we have launched industry-leading experiences like skin tone ranges, which give pinners the tools to find the beauty results that are just right for them and their complexion. This work improved skin tone diversification in recommendations by more than 4 times. And just recently, we announced our new body type technology. This is an industry-first, patent-pending technology that uses shape, size, and form to identify various body types or images across Pinterest. With this signal, we have improved body type diversification by more than 5 times. Our users love these features. They tell us this is a core reason they choose our platform over our peers. They like feeling seen, and that is driving increases in sessions, saves, and impressions. Next, I would like to talk about shopping, which is the key for our pinners to go from inspiration to realization. I would like to introduce Shop the Look and also Visual Search. Both are built upon the state-of-the-art computer vision technology at Pinterest. When our users see an inspiring pin on home feed or search, they often have a challenge not knowing where to buy those products in the pin. With our Shop the Look feature on close-up that shows the exact match or highly visually relevant product to the pin, user can now easily discover where to buy the products they see in the inspirational pins they love. Another product feature is visual search. There, we enable our users to see related items that may fit their style or budget better. What this means is, let's say you like a green purse, but it might be very expensive. It might be at a price of $700. You might be thinking, can I actually buy the similar purse, which looks very similar, however, much cheaper? Or you may be thinking that how do we find a purse that better fits my style? By visual search, we can show you dozens or even hundreds of similar items to find a match just for you, according to the budget you have, according to the style that you may like. Now, I want to introduce a technology that unlocks an all new level of saving and curation on Pinterest. This is called atomization. Atomization breaks down complex scenes into individual elements. The first phase of atomization is cutouts. Cutouts enable our users to extract and save just the elements they love most within a pin. Let's say you come across a home decor pin with a lamp, which may be perfect for your bedroom. With cutouts, you will now be able to cut out that lamp and just save that lamp into the board instead of saving the entire pin. That is shown on the left image of this slide. So once the lamp is saved to the pinner's board, now the user can use collages that can empower them to visualize, curate, personalize, and also share their ideas with other pinners. Suppose the pinner have saved a few cutouts. You can see that on the right side of the image. The pinners can now be able to create a totally new content for Pinterest by simply combining all the cutouts they have saved into the new pin. So this is a very, very powerful feature, and it's going to be very unique for Pinterest. So with all the machine learning technologies and product that I have shown just to you, now I would like to spend the next few minutes talking about our machine learning infrastructure. Machine learning infrastructure are the foundation for our actual large machine learning models to be able to become scalable in training and also serving with low costs and also low latency. In industry, this is definitely a challenge. We also face the same challenge, and I'm going to talk about how we are able to do that. I want to start with introducing Machine Learning Inf, MLInf, which is a machine learning development framework that aims to make machine learning engineers more productive by abstracting away technical complexities that are irrelevant to machine learning model. MLInf standardizes the code runtime and build environment components so that the MLInf can set them up once, and every machine learning project that onboards to the MLInf can skip these steps. There's also a ML Dev toolbox, which is a set of commonly used tools in machine learning development that can help our machine learning engineers be more productive in training and deploy the models. Our machine learning engineers are able to use most of these tools through configs and skip integrations, which were usually very time-consuming. Last but not least, MLInf gives everyone access to advanced functionalities that can be easily shared across teams. Our machine learning modelers also have access to a portfolio of training techniques that can help speed up their training, like distributed training and mixed precision training. On the serving side, we have highly optimized machine learning components for online serving using GPU. With MLInf, our machine learning modelers can focus on the interesting part, which is the logic to train our models. This has dramatically improved our developer productivity on machine learning and enabled technical leverage across different surfaces and teams. With the massive amount of data we have and need of more than 400 million inference per second, we have to build a scalable and cost-efficient machine learning infrastructure. We not only enable GPU serving, but we have also optimized our training and serving using mixed precision and CUDA graph optimization. So although the model size has increased 100 times, we'll talk about that for home feed example, the cost increase or latency increase are actually very little. We also have a unified training compute platform. We have training data engine. We have centralized feature store. We also have a unified feature representation to make sure that we can maximize machine learning productivity and also leverage. Finally, we also have an automatic retraining framework to make sure our models are regularly retrained to remain fresh. Okay, with all this said, it is time to look at the future of machine learning at Pinterest. First of all, we will continue to invest into user and content signals to make sure they can represent the state of a user's journey, their taste, their preferences, their styles at the moment when visiting Pinterest. We would also like to grow our models even larger with little latency or infra cost increase. We believe by growing our model larger with more parameters, with more data, we will be able to continuously power our recommendation system and search systems, or even those kind of machine learning product features in a much better way. We also think it is very important for us to do joint optimization of Pinterest journey across different surfaces, like home feed, search, and close-up. What this means is we need to be able to share our signals, share the data. We need to be able to jointly consider where the Pinterest states are when they visit Pinterest, when they visit different surfaces. We need to think about where they are, like are they in the inspiration mode or are they in the realization mode? So we can serve them with the best experience of either the inspiring content, or the content they may want to purchase. Next, we are in the very incredible position to continue capitalizing on the state-of-art Gen AI models to enhance everything we do for our users, our advertisers, our backend systems, and our employee productivity. So we are developing and piloting the following generative AI-powered product features. The first one is called Creative Studio. We plan to take our product pins with white background or low resolutions, and then render them in generated lifestyle images with high quality resolution and attractive backgrounds. Second, we are experimenting with generated search guides. Generated search guide is a Gen AI-powered evolution of search that aims to help our pinners with broad interests break down their projects, learn more, allowing them to learn more about the possibilities in the space, and also surface the unique inspiration they never would have sought to look for themselves. Third, we are experimenting with personalized insights, which is taking the pins from our users' board and telling them verbally their personalized styles, so they can use those to further explore the ideas they are interested in. Under the hood, we are also using generative AI to improve backend search quality and content understanding. This will make Pinterest better for more ideas around the world. And last, but definitely not the least, we are already seeing generative AI or LLM technology improving our internal productivity with engineering-specific projects like Coding Copilot and data labeling with better speed and quality with lower costs. We believe generative AI will benefit from our unique signals. It will evolve our world-class AI platform we talked about, and it will continue to make our unique strength in AI even more prominent. So that's the end of my talk. And I want to provide you a summary and leave you with a bunch of takeaways. First, Pinterest is a unique platform that brings our users an inspiration to realization journey. Our mission is to bring everyone the inspiration to create a life they love. Our users come to our platform with very strong intent, and they would like to take actions when they are actually inspired. Saving is one of the key product features that make us unique and provides great signals. Second, Pinterest is powered by large state-of-art machine learning systems that are built upon rich content and user signals. We also have many impactful machine learning-driven products, including inclusive product, shop the look, visual search, and atomization. And third, there are a ton more to do in machine learning. For example, we want to be able to build large models. We want to build better signals. We want to do joint optimization across different surfaces. And we want to invest in generative AI to be able to power both our product in a better way, as well as our developer productivities and internal labeling, etc. So that's the end of my talk. And I believe we have plenty of time for questions.
Thanks, Liang. Yes, we have a couple of questions. So the first one is, how does Pinterest capture predict the transition of pinners' interest? For example, the diagram you showed food for a while and then transition to dogs.
Okay, that's a great question. So first of all, that is exactly why we use the transformer into our architecture, model architecture, because we believe if we use this user sequence into our model architecture, we build our user sequence in transformers by predicting the next action that people would take in their journey. So by incorporating such user sequence model into our machine learning models, we believe we should be able to, deeply using deep learning to deeply understand what pinners have been doing in the past sessions or in the long past, right? Because transformer actually is able to do that. And what are they going to do next? Which I think is the main question that the model can capture, right? On top of that, we also have a lot of other signals that we have. For example, we have the user intent signals that we want user intent and user interest signals, which says in general, what are the users interested in the last, say, 30 days? What are they interested in right now, right? What the intents are when they are visiting Pinterest, or what are the intent are when they search for these queries on the Pinterest search. So because of the strength of such signals, all the word color signals that we talk about, and because we have deep understanding of our content, that is the pin stage embeddings that I was just talking about, and all the other content signals I just talked about, we are able to use transformer-based user sequence model and incorporate those in our recommendation systems, so that we are not only able to accurately predict the next actions, we're able to use that prediction power to be able to serve the most relevant content to our Pinterest users. Hopefully that answers the question.
Great, thank you. All right, moving on to our next question. What is Pinterest thinking of taking their 1B parameter images model to the growing technologies such as large language vision model to search and have a better pinner experience?
Yeah, so this is a great question. I do want to say that, first of all, we do have text embeddings. We also have image embeddings. And we are also trying to figure out how can we incorporate the text and image together, do multimodality into our signals. And how can we use both images understanding and also text understanding as a way to be able to power search? I think this is a very good spot on question. I would say there's a lot of work in progress, right? And we are actively experimenting, we're innovating. Definitely, I think this is a great future that all the entire industry is working on, right? And LLVM is definitely one of them, right? So I think we are actively innovating and looking at those technologies, and we do want to try those ideas in our production system. And our machine learning foundations is so strong so that all of our machine learning developers very easily be able to experiment with those great ideas at Pinterest. That is, I think, where I do want to double down a little bit more on about machine learning infrastructure. People who join Pinterest as machine models are having a very good time because they are able to easily launch all these great ideas into production systems. And we have a lot of GPU optimization, CUDA optimization. I talk about that also helping you because in a lot of challenges from those large models are actually serving, right? Can we actually serve them with very minimal cost? Can we actually serve them with very low latency? That's why we spend a lot of time in infrastructure to make that to become efficient. There are a lot more work to do. I'm not saying we have entirely solved the problem. No one has solved the problem, right, fully. But we are one of the front runners in terms of being able to serve such a large scale system with large scale models and being able to power our production system really, really well and efficiently.
Great, thank you. Our next question, for being inclusive, are we also taking into account the different cultural vernacular languages being used?
If I understand correctly, this is more about the language support, right? So I think I still remember 1 year ago when we had this similar machine learning day, we said, how many languages are we supporting? At that time, it was 35. And now we are 40. So what I'm trying to say is that we have been continuously looking into this domain and try to make sure that we are able to support more and more languages over the time so that make sure that the platform can become more and more inclusive. This is definitely on top of our mind right now. By the way, we also actually have a team that focus on the language support. And every year we will focus on a few important languages that I think we will be best to serve our partners and best for our international growth and best for our inclusive product. So definitely on top of our mind.
All right, our next question. Does Pinterest utilize all of the user action signals or does it filter out outlier noisy signals in user actions?
Yes.
Are there any checks to measure for statistically significant user signals?
Yes, I think the answer is yes. First of all, every platform would have the same problem. They have a lot of spams, right? Pinterest is also same, right? So we do have some users who are like bots. We have to filter them out because if we don't filter them out, then our signals will be polluted. And we are making sure that our machine learning systems are actually using the very high quality data. So that I mean, as a machine learning modeler, we all know how important data is, right? We definitely look very carefully about who are the users' data that we should use, and making sure that we remove all those spamming behaviors, removing all those bot-like behaviors, so that our model can become very clean.
Great. Thank you so much, Lan, for kicking us off at ML Day. We're going to take a short break and then we will.
Thank you.
Great. Thank you.